Greetings on this beautiful day. I hope everyone is good. I hope everyone is blessed. I hope everyone is ready for our class today. Just give me 2 to 3 minutes. Wait for others to join in and have it in the active section to get. I hope everyone is blessed. Everyone is ready for our class today. Awesome. Who do we have here? Who do we have? Feel free to type something on the comment section. Feel free to type something on the web comment section. Who do we have here? Just say hi or just say Dumelang. If you are suited to just say Absheng. And let's talk together. Let's talk together. All right. Awesome. Today we will be doing trigonometry grade 12 and grade 11. And it's so fantastic that today we'll be able to do that trigonometry. It carries plus or minus 40 marks. It carries plus or minus 40 marks in your final paper, and also in June, and also in your trial exams. It carries plus or minus 40 marks. So please bear in mind that this is an important topic which you must be able to grab and understand. So please, if you have any questions, stop me so that we can be able to do this together, and I'll be able to assist you as much as I can. All right. Great. So today we'll be doing trigonometry, and bear in mind that trigonometry is the most important section, which I feel like it's so easy that you can grab marks on. As you can see, I just showed you like a past previous question paper. Trigonometry is the greatest because it's just almost straightforward. You just need you to practice more. It has a lot of things which you are relevant to, and it's so fantastic out that you just have to practice more questions. The setting of the question paper is always the same. So let's get the ball rolling. Okay, so let me just start with a short overview. I love overviews a lot because they'll give you a background of what's being happening before we attempt questions. So let me start with a short overview today. So today we say we're gonna do trigonometry. Please don't kill me if my spelling is wrong. So today we're gonna do trigonometry. Great. So what I want us to do now, let me just do revision on trigonometry. So we started to do trigonometry in grade 8 and grade 9. And in grade 8 and grade 9, you were taught about these three aspects, that we have what we call the Pythagoras Theorem, and we were applying it also using angles. And we say that we have what we call the opposite side, the hypotenuse, as well as the adjacent side. So given angles, you can be able to calculate the missing sides and be able to calculate everything which are given. For instance, we are given this kind of triangle, a right-angled triangle. So this is what we call the opposite side. Opposite. This is the adjacent. And this is the hypotenuse. Hypotenuse. So when we are given this kind of triangle, which is a right angle triangle, we were taught in grade 9, grade 10 that this is a right angle triangle, and it consists of a 90 degrees. That's why it's called a right angled triangle, because in order for something to be a right angled, it must have a 90-degree angle. And now we also have our theta here, which is the included angle. So given in this scenario, this will be our opposite side. Bear in mind that this opposite side, it's a line which is opposite to the angle, and the side which is opposite to the 90 degrees is called the hypotenuse. The side which is opposite to the its hypotenuse. So it's so important that we can be able to grab that concept and we move on together. Okay, so it's so important that we understand that this line here is the opposite. It's opposite to this angle, and also when it's opposite to 90 degrees, it's called hypotenuse. So now we were taught that sine of theta, where is sine theta? Sine theta is here, is equal to opposite over hypotenuse. So we're just refreshing our memory. Then we're also taught that cos of theta is always equal to adjacent over hypotenuse. Then the last part, number 1, number 2, number 3, we were also taught that we have tan of theta, which is equivalent to come on, help me. Tan theta is equivalent to opposite over adjacent. So before I just start there, let me just say here so that you cannot get lost. So in trigonometry, we have 3 trigonometric ratios. We have sine theta. Theta is just an included angle, so this can change. It can be x, it can be y, it can be z, it can be alpha, it can be beta, but that theta is an angle. So this is usually called as cosine to represent sine. Then we also have cos, and it also have an angle theta, and also have the third trigonometric ratio, which is tan theta. So we are saying that according to a right angle triangle, which we were taught in grade 8, grade 9, we were taught that we have a triangle which is a right angle triangle, which consists of the opposite side, the adjacent side, as well as the hypotenuse. And we say that in order for us to be able to calculate sine of theta, we look here and we say it's opposite over hypotenuse. And bear in mind that the opposite side, in order for you to see the opposite side, look at where your angle is. The angle theta which you are given, where is it? Then now just draw a line where there is an opposite side. That's where you see the opposite side. If we're given angle beta here, what is the opposite of angle beta? We were just going to draw here. So this was going to be the opposite now, because you look, the opposite side of the angle is the opposite side which we are considering in this. And also on this same instance, we were taught about the Pythagoras theorem. Pythagoras theorem. It's so essential that you remember this, because it's important that you understand the Pythagoras theorem is only used when it's a 90 degrees. Okay, so we have our ADJ, we have our opposite side, we also have our hypotenuse. And when we draw this on a Cartesian plane, we can see that this is the x, this is the y, because this is the x-axis, this is the y-axis. So we can see that this is the y-axis, and also this is our angle theta. So this will be r. So according to the Pythagoras theorem, it's always equal to the hypotenuse. O squared is equal to opposite side, is equal to adjacent side. O squared plus the opposite side, which is the same as r squared is equal to x squared plus y squared. So this is so important that you understand that this is the Pythagoras. This is our Pythagoras theorem. All right. So this is our Pythagoras theorem. So now let's move on now to our grade 11 work. In grade 11 now, I want us to start with what we call the reduction formulae. The reduction formula. So in grade 11, we were taught about the reduction formula, and this is so important. So in the reduction formula, we are reducing angles with the right angles which we know. So for instance, let's just check this out. We are having this Cartesian plane. It has 4 quadrants. It has quadrant 1, quadrant 2, quadrant 3, quadrant 4. So what do we have here? So we say that in trigonometry, we are looking at 3 trig ratios which we have. We have sine of theta, we have cos of theta, as well as tan of theta. So what do we have here? So now we have to understand that in these different 4 quadrants, this specific quadrant, only one trig ratio will be positive in there and others will be negative. As also, when we are looking on other side also, that we understand that when we are reducing those big angles, maybe for instance you are given angle 400 and you can see that plus 400 is in quad 4, and you must know that it's 360 plus that specific angle which you are given, so that you can attain the angle which you must get. Then that's how we reduce, and also using the special angles, 60 degrees, 30 degrees, 40 degrees, 45 degrees, as well as those three special angles. Those are so essential and so important for you to know. So bear in mind that this in our reduction formula, I want to understand that all the trigonometric ratios in the first quadrants, they are positive. Bear in mind that when we are doing Euclidean geometry, we say that a straight line is equivalent to 180 degrees. So since a straight line is equal to 180 degrees, so when we divide that straight line into two, it's going to be equal to 90 degrees. So now we have 90 degrees here. So 80 degrees, 180 plus 90 degrees, now we have 270. So in this first quadrant, I want us to understand that in the first quadrant, it's 90 degrees minus, okay, minus theta. Let's just use theta because this is our angle, okay? So everything which is 90 degrees minus, because when we are moving backwards, it's 90 degrees minus theta, okay? Then in the second quadrant, it's now 90 degrees. We are going forward now, it's 90 degrees plus theta. And also when we are coming back, it's now 180 degrees minus theta, okay? Then moving forward again, it's now 180 degrees plus theta, and it's also 270 degrees minus theta. And we also have 270 degrees plus theta, okay, because we are moving forward. And we also have 360 here. So we have 360 degrees minus theta. Then in the first quadrant also, we have 360 degrees plus theta. So now we want to substitute the correct trig ratios. So we say that in the first quadrant, all the three trig ratios are positive in the first quadrant, and in the second quadrant, only sine of theta is positive. So in other words, when we are given sine of 180 degrees minus 70 or minus 60, you definitely know that your sine is positive because it's situated in the second quadrant. Then on the third quadrant, it's 180 degrees plus theta and 270 degrees minus theta. Then the only trig ratio which is positive here, it's tan of theta. And the last quadrant, we have cos of theta. So bear in mind that many students always say that all students take coffee. Others say all students take caffeine. It's just different. People memorize this thing in a different angles. So it's also essential that you understand that this is your reduction formula. So here, what you have to understand is that in the first quadrant, all the trig ratios are positive. So all of them, if you are given sine 90 degrees minus something, tan 90 degrees minus something, tan what minus something, know that this is in first quadrant. Then now, I want to also touch this aspect that we have what we call co-ratios, okay? So on the co-ratios now, they only apply on two, sine and cos. So when you're given sine 90 degrees minus theta, we are also given sine 90 degrees plus theta. We are having also cos of 90 degrees minus theta. We also have cos of 90 degrees plus theta, which is equal to. So we are having these four trig ratios, okay? So on these four trig ratios which we are having here, I want us to understand one thing here. These are called co-ratios. In other words, they swap. So what is Vian saying here? So what is important is to understand that on the co-ratios, when it's sine 90 degrees minus theta, it will change to cos theta. Now, check something. In order for you to reduce angles, if you are given in this sense, you have to go to your reduction formula and reduce from your reduction formula. So for instance, in this instance, we are having sine 90 degrees minus theta. So what's the first important thing? I'm going to give you 3 steps. When you're given reduction, this kind of a trig ratio in this format, the first thing which you do, I always advise, draw your reduction formula so that you don't get confused. So in this instance, our reduction formula, it's here. So here we start by looking at your angle. So what is our angle? Our angle is sine it's 90 degrees minus theta. Where is 90 degrees minus theta situated in our reduction formulae? It's situated in the first quadrant. And how is sine in the first quadrant? Sine is positive. So now the co-ratio of this sine is also going to be positive. Let me repeat this again. So what you do here is that when you are given this kind of scenario, you must be able to understand and be able to see that you first by looking at what you are given inside the brackets. So in this instance, they are saying that 90 degrees minus theta. So you got your reduction formula, which you have drawn first, and 90 degrees minus theta, it's in the first quadrant. So since it is in the first quadrant, what is the sign of sine theta in the first quadrant? We know that sine it's positive. So also the co-ratio is gonna be positive cos theta. Then now also on the sine 90 degrees minus plus theta, we do the same thing. We check the angle, which is 90 degrees plus theta. This is second quadrant, 90 degrees plus theta. What is the sign of sine? Sine theta is positive in the second quadrant. So also the co-ratio is also going to be positive. Then we go to cos 90 degrees minus theta. So cos 90 degrees minus theta, again, we first start looking on our reduction formula. And when we look on our reduction formula, we must be able to see where is 90 degrees minus theta. 90 degrees minus theta is in the first quadrant. And what is the sign of cos theta? Cos is always positive in the first quadrant, which means also the cos ratio is also positive. So it's going to be sine theta. Then cos 90 degrees plus theta. So the first thing again, we're going to start looking at the angle. So 90 degrees plus theta is situated in the second quadrant. Okay. So since it is in the second quadrant, cos it's the only trig ratio which is positive in the second quadrant, it's sine of theta, which means tan of theta, if it's situated in the second quadrant, it will be negative. If cos of theta is situated in the second quadrant, it's also going to be negative. So also in this instance, we are having cos 90 degrees plus theta. We first look at our angle, which is 90 degrees plus theta, and we can see that 90 degrees plus theta is situated in the second quadrant. So since it is in the second quadrant, we can now conclude that no, man, we know that in the second quadrant only sine theta is positive. So in this case, our cos theta now will be negative cos of theta. So this is our co-ratios. We usually use them when we are proving identities. We usually use them when we are solving equations. We usually use them when we are solving our questions which we are given in a question paper. All right. All right. Is there anyone with any question? Before I move forward? Is there anyone who wanna say or wants to ask something? All right. Thank you. Let's proceed. Now, I want us to look at these negative angles, which you must understand. Negative angles. So when we are having negative angles, they're only, I'll just use the 3 trigonometry ratio. So when we are given sine of negative a, it must always be negative sine of. It's always the case. You can confirm this using your calculator, and you'll be able to see that negative sine of any negative angle. A in this case is my angle. So maybe I give a negative 30 is going to be equal to negative sine of 30 degrees. Okay, so always know that when you are given sine of a negative angle, your result will be negative. All right. Number 2, if you are given cos of a negative angle, your result will be positive cos of that angle. Then the last one, the tan. If you're given tan of a negative angle, always know that it's always negative tan of a. So the only trig ratio which is not affected by the sine of the angle, it's only the cos of a. Okay. All right. Now I want us to move, and I want us to speak about special triangles. Come on. So on special triangles, I have 2 special triangles which are totally different. And these special triangles, you must know them by your head. You are not allowed to use your calculator when you are asked to simplify without using a calculator. So in those instances now, we want to teach you that you'll be able to understand that these special triangles, they are essential because inside they contain the special angles which include 30 degrees, 60 degrees as well as 45 degrees. So these special angles will be able to assist you when we are reducing angles which we are given. For instance, we are given sine of sine of 270, or maybe you are given sine of 135. We will know that sine of 135 is in the second quadrant, and we know that it's 180 degrees minus. So what do we do in that instance? We just say sine of 180 degrees minus 45 is going to be equal to 135. So now we are now dealing with that small special angle which we have. Then when we reduce it, now we'll be able to see and analyze and be able to say, no, this is really why we are using them. Because the moment you use a calculator, the examiner or the marker of your paper will say that you used your calculator. So please, when they say that don't use a calculator, prevent the use of a calculator, because you will be rewarded partially when the teachers are marking. So please also bear that in mind. Okay, so I have two triangles which I call special triangles. So I have my 90 degrees here, I have my 60 degrees here, I also have my 30 degrees here. Okay, so we know that the sum of angles in a triangle are always supposed to be equal to 180 degrees. So 30 plus 60 is 90 degrees, 90 plus 90 is 180 degrees. So that's a full triangle. Okay, so now since it's a full triangle, I want us to understand something now, that there must be values here. Okay, there must be values on the opposite side so that you understand them. So it's always 1. Okay, we also have root 3, and we always have 2 here. Okay, I put my 2. So this is the special triangle. Okay, with special angles. For instance, example e.g., if they say sine of 30 degrees is equal to opposite. What is the opposite of 30? We say that the opposite side of that specific angle, the opposite side. So we know that sine of an angle is the same as opposite of a hypotenuse. So what is our opposite side? It's 1 over 2. So if they say number 2, sine of 60 degrees, you do the same thing again. This is the opposite of sine of 60, so it's going to be equal to root 3 over the hypotenuse. Hypotenuse is always the longest side, and the longest side is always opposite the right angle, or the 90 degrees angle which we are given in the question. So bear in mind that this is so important and so essential that you understand that concept, so that you cannot forget this. So as I was saying earlier, that you are not allowed to use your calculator in this kind of instances. When you're given this kind of question, make sure that you don't use your calculator in the process, because you won't rewarded full marks. So this is my first special triangle. If I say cos of 60 degrees, we know that cos is always adjacent over hypotenuse, so it's going to be 1 over 2. So now my other second triangle, now I have this triangle. Let me try to draw something nice. Okay, 90 degrees. So I have this triangle again of 45 degrees. Okay, this is also a special angle. It's also a special angle. So these are the length. It's 1, 1, and square root of 2. So I want you to understand that if you use your calculator now, can you just try to use your calculator right now and say maybe sine of 45 degrees? Sine of 45 degrees, it's, when you use your calculator, it's root 2 over 2. So the marker will see that no, you use the calculator, then after that you get a 0. So using our special triangle, always know that sine of 45 is 1 over root 2. You see, that's the already difference. Then also you can also see that cos of 45 degrees is also 1 over root 2. So you must be careful of those things, that you don't use your calculator in the process. Please be careful of that. Now we have what we call general solutions. We were taught this also in grade 11. General solutions. So the general solutions, I have 3. We said we are dealing with 3 trigonometric ratios. So for instance, we are given sine of x is equal to a. So they ask you to determine the trig ratio in this instance. So how can you determine the trig ratio in this instance? You must be able to see, and you must also know. So now in general solutions, if sine of x is equal to a, provided the a is from -1 to +1. So the general solution then, the general solution of sine will be equal to x is equal to the calculated angle plus 360 degrees of k, or x will be equal to 180 degrees minus the calculated angle of A plus 360 degrees of K. K is the element of integers. Okay, so that's our general solution of sine. Okay, so we're saying that if sine of x is equal to A, provided that A is situated between -1 and +1, we can be able to determine our calculated angle. So when we are calculating our calculated angle, that will be able to make you be able to understand the concept behind everything. Okay, cool. Now, moving on and moving to the next step now, this is for sine theta. Now let's do for cos theta. So if you are given cos of x is equal to A, so in this instance again, we also know that if, let me just remove this, if cos x is equal to A, then the general solution will be plus or minus the calculated angle plus 360 degrees of k, where k is the element of integers. Right. Then the third one is tan of x. So can we just say if tan x is equal to A, provided, guys, you know that it's always provided -1 is less than A less or equal to 1. It's always that case, all right? So if tan x is equal to A, provided A is an element of any real number, the general solution will always be called x is equal to tan inverse arctan, yes, arctan of A plus 180 degrees of k, where k is the element of integers. So bear in mind that the tan has asymptotes on 90 degrees, 180. So also bear in mind, this is so essential. This is how you determine your general solutions in all the equations. When they ask you to determine the general solution, if it's cos, please use this formula. If it's sine of theta, can't move. Okay, if it's sine of theta, please use this general solution. So this will be able to help you and make you understand the concept of general solutions. Okay, now I'm done. Now let me just do an example, just do an example so that you get the concept of what I'm talking about. So for instance, you're given sine of theta is equal to 0.5. So what are you supposed to do? How do you calculate the angle theta here? I'm just going to do 2 examples so that they say determine determine the general solution of this problem. So you're given sine theta is equal to 0.5. Now they are asking you to determine or to calculate or determine, the general solution. How do you do that? So always we know that we calculate the angle first and we transpose sine. When it goes to the other side, it will be sine inverse. It's called arctan actually. Yeah, it's called arcsine. It's called arcsine since it's sine. If it's tan, it's arctan. If it's cos, it's arccos. Like this, arcsine theta or arccos. So it's only illustrated by that as sine inverse. Okay. So we put our 0.5. Then we use our calculators. Then we'll get 30 degrees. Then you are done getting the angle. Then therefore, to determine the general solution, you write the general solution. Okay, so we say the general solution of sine is determined by saying that the calculated angle, this part is representing the calculated angle. Bear in mind that here we also said sine inverse or the arcsine of 0.5. Then the same part here, it's arcsine plus 360 degrees. So what was our arcsine? It, in this case, our theta was 30 degrees. So it's just 30 degrees plus 360 degrees of k. Okay, or theta, we said, or theta can be equal to 180 degrees. Where is it? 180 degrees minus the calculated angle. This is illustrating the calculated angle, guys. So it's 180 degrees minus the calculated angle. 180 degrees minus the calculated angle. In this instance, the calculated angle was 30 degrees plus 360 degrees of k, where k is the element of integers. So we might subtract, then we'll end up having 150 degrees plus 360 degrees of k, where k is the element of integers. Make sure that you see every time when I'm writing my second general solution, I'm always inserting the fact that k must always be the element of the integer. So also you please don't forget to include that. It's so important that you include that in your questions. All right, please make sure that you include that as well. All right, now let me just do another example for you guys so that you can see that I'm not a bad person. So let me just give you another example. For instance, maybe you're given cos of 2x is equal to 0.5. Yeah, let me just give you this one. Or let me just say cos of 2x, yes, is equal to 0.25. So in this side, you see that 2x is a whole angle. Okay, so we are having 2x as an angle. Just like here, we were having theta as an angle. So it's the same. 2x is equal to cos inverse of 0.05. So actually, you must be able to determine the calculated angle. So in this case, when you say arc cos of 0.5, I think you must get 60 degrees. Okay, you must get 60 degrees when you use that. Then you leave it like this. Okay, don't divide both sides by 2 because you must divide in your general solution. That's why I did this example, because I feel like it's so essential that you understand that concept. So general solution in this instance, so we say that the general solution of cos is always equal to x is equal to plus or minus the calculated angle plus 360 degrees. So in this case, you are having 2x. So it's always 2x is equal to plus or minus the calculated angle, which is 60 degrees, plus 360 degrees of k, where k is the element of integers. Then now that's when you can divide both sides by 2. Then you're left with x is equal to plus or minus 30 degrees plus 180 degrees of k, where k is the element of integers. Bear in mind that if you're gonna divide here, it was only gonna be 30 degrees on the calculated angle, but in this instant also it shortens the period. 360 degrees of k is representing the period of cosine. Okay, so the period of cos and also the period of sine is 360 degrees, and the period of a tan is a tan graph is also 180 degrees. So it's so essential that when now we are dividing, we also divide both sides with also our angle, so that you can be able to calculate and also reduce the period. So I wanted to show you with those two examples. And also sometimes, you know, we can be given this kind of question which is hard. Say like, oh, it's hard. So in this question, in this instance, they say determine the general solution. What can you do in this instance? What can you do in this instant? You can just divide both sides by cos x. Okay, divide both sides by cos x. Then now we are left with sine x over cos x is equal to 1. And you know that tan x over cos x is the same as tan of x. I'm going to talk about right now about identities. Then you end up having x is equal to tan inverse of 1, and we end up having 45 degrees, because tan inverse of 1 is 45 degrees. Then therefore the general solution will be x is equal to, we say that the general solution of a tan is 45 degrees, which is the calculated angle, plus 180 degrees, which is the period of tan graph, k, where k is the element of integer. So that's when, and that's that, and we are done. Anyone with any question on that part? Now I want us to do identities now. So in grade 11 we were taught about these identities, so I'm just going to combine grade 11 and grade 12. So in grade 11 we were taught about that tan of theta is always equal to sine theta over cos theta. We need these things so that we can be able to prove. When they ask us to prove, we must be able to prove. Then the second one, we were given that sine squared of theta plus cos squared of theta is always equal to 1. I always have three identities because I have 2 only in grade 11, but I can be able to make one of them the subject of the formula. For instance, sine squared of theta will always be equal to 1 minus cos squared of theta. So I already made another trig identity on my own. And also when we make cos squared of theta the subject of the formula, to be 1 minus sine squared of theta. So I've already made those 2 alone, so that you can also be able to see and be able to detect and see those. Now in grade 12, now we were taught about double angles. In grade 12 we have what we call double angles. In grade 12, we have what we call double angles. So on double angles, I want us to understand something which is so nice. Double angles, they are a bit tricky, but you can understand them. The first double angle, its sine of 2a is equivalent to 2 sine a times cos of a. Okay, that's a double angle. Then the other one, when you are given cos 2a, it can be equal to three things. It can be equal to 2 cos squared of a minus 1. It can also be equal to 2.2. It's 2.2 cos 2a. Double angle, of course, can be equal to also 1 minus 2 sine squared of a, right? And also it can also be equivalent to 2.3 cos 2a, which is a double angle. It can also be equivalent to cos squared of a minus the sine squared of a. You can be able to prove these things, guys. For instance, let me just do a short proof so that you can see. Cancel. Let's try to use the black. Let me try to prove from this one to form other ones. Okay, so 2 cos squared, just say 2 cos squared of theta minus 1 is the same as, this is something which we know it's a identity, and which is equal to 1 minus 2, 1 minus sine squared. So we can just say 2 1 minus sine squared of theta minus 1. Then that will be equal to 2 minus 2 sine squared of theta minus 1. Grouping like terms, then we have 1 minus 2 sine squared of theta. So this one is formed from this first one, which is giving us that one. And also we can form this one again by making 1, we know sine squared of theta plus cos squared of theta minus 2 sine squared of theta. Then we end up having sine squared of theta, they are like terms, plus cos squared of theta. Then that's the same as cos squared of theta minus sine squared of theta. And this one is just this. It's just this, the last one. So we must also be able to prove them. They'll just say, given that cos 2a is equal to cos squared of a minus 1, then prove that, or find these other identities, so you can be able to find the double angles identities also at the same time. So those are our identities, guys. Please always know that them by heart, that these are our identities. So these are from grade 12 now, double angles. So also in grade 12, the last thing which I'm going to talk now is that we were taught about what we call compound angles. So on compound angles, I want us to understand the fact, three things on compound angles. I want us to understand number one, we have the compound angle of sine of a plus b, which is always equal to sine a times cos b plus cos a times sine b, sorry. The number two, we have sine of a minus b, which is always equal to sine a times cos b minus cos of a times sine of b. Then we have the one for cos now. That's where things changes, because it's the same as cos sine. Okay, so now when it's positive here, check it out. When it's positive here, it's gonna be negative here on the compound angle. Then we also have the last one, number 4. When we are given cos of a minus b, it will be same as cos of a times cos b. It's minus here, so here is gonna be positive. Okay, sine b times sine b, then this side it will be positive, right? Okay, so this is our trick. Then those are our compound angles, guys. Please don't hesitate to ask if you have any question. Okay, right now the last thing which I want to talk about is last thing I want us to talk about is what we call the sine, the cosine, and the area rule. So now we say that we know from grade 10, grade 9, that grade 8 as well, that in order for you to calculate the area of a triangle, it must be a right angle triangle. We always know that the area of a right angle triangle, for instance like this, it's always equal to half base times height. Okay, but now in grade 12 and also grade 11, now I want us to understand that we can be able to calculate the area of any triangle. Bear in mind that we have different triangles. We have isosceles triangles, equilateral triangles, scalene triangles, right angle triangle. So we can now be able to calculate now the area of these kind of triangles now, which are not right angled triangles. So I want us to understand that now we can be able to, for instance, we are having this triangle here. We're having A, we also have B, we have C. So I'll use small letters now. We said the opposite side of A will be small letter A. The opposite side of B will be small letter B. Opposite side of C, small letter C. Okay, so maybe we are given an angle here. Okay. So the area rule now in this instance, it will be equal to, so you just say area, just right here at the bottom. So in this instance, we will have the area of triangle A, BC, which is equivalent to. So now we look at where our angle is, and we look on the two sides on which our angle is lying on. Okay, so what is important now is to be able to determine the area rule, because it's so important to understand the area rule, right? So now in this case, now we are given this angle here. I hope you can see my angle theta here. So it will be equal to, this is our angle theta, it's between these two sides. So it's gonna be 1/2 of AC times AB sine of theta, which is the same as 1/2 BC sine of theta. Let me repeat again. So in area rule, we look at two sides which we are given and then include an angle. So for instance, we are having something like this, and this is our angle. So we use these two sides, and we say 1/2, which is half of, you multiply this side and also this side, and you also use the included angle, which is in between, so that you can be able to determine your area rule. So for instance, if we are given that the angle is not here, use a different pen. If you're given that the angle is not here, it's here. If you're given that the angle is not here, it's here. Let's choose something great. Then the angle is this side. So we can see that the angle is between these two sides. So again, the area here was going to be equal to 1/2 of AB sine of that angle theta if it's here. So in area rule, we are just looking at these two sides in which they have the included angle, so that we can be able to determine the area of the triangle. It no longer have to be a right angle triangle or a triangle which has a height, a perpendicular height and stuff. Any triangle can now be able to determine its area. Okay, so number 2, I have what we call the sine rule. So again, I have this triangle. Let me just put A, B and C. So again, the opposite of B is here, small letter B. Opposite of C, small letter C, small letter A. Okay, so how do we do with the sine rule now? So the sine rule is the easiest one now. It's so easy. If you want to calculate a missing side or missing angle, it's so easy. So how do we do that? So it's always sine of A, angle A, then it goes with its small letter A. So this angle and this small letter A is always equal to sine of C over small letter. These are angles, these are sides. Then also equal to sine of B over small letter B. So this is our sine rule. So if, for instance, you know these two sides, but you want to calculate one of the angles, you can also use the sine rule. Then the last one, we have what we call the cosine rule. We have the cosine rule now. This is the last thing I'm going to talk about in trigonometry. So maybe we are having this triangle A, B and C. Then maybe again the opposite, A, opposite B, C. So the cosine rule, guys, it's not hard. again, we must know our included angle also in this situation. So for instance, we have an included angle here. So this is where the included angle is, and this is our B. So you can be able to calculate B by just writing that B. Now, you see, it's so easy. You just have to understand the concept of what's really going on here so that you can be able to determine the sine rule. All right. So in this instance, our B will be B squared is equal to, now we look at the two sides which are having the included angle, which is A squared plus C squared minus 2AC cos of the angle B, which is theta. Okay, let me repeat this. Okay, so now with cosine rule, if we are given this angle here goes along with its side. So if you want, maybe we are given this angle now, angle C. If you are given angle C, which means we will be able to calculate the distance of C. If you are given angle A here, we will be able to calculate angle A. So for instance, we are given angle A for this time. Okay, so we're given this angle A. So how do we do it? A is opposite to this small letter A, so it's gonna be A squared is equal to, this is our angle A, and it's having these two sides which are in contrast, or which are with contact with the angle. So it's gonna be B squared plus C squared. Okay, A squared is equal to B squared plus C squared minus 2 BC cos of angle A. So same applies also if you want to calculate the length of C or angle of C. So also if you are given angle C, guys, C squared is equal to, where is C? Here is our C. Okay, so it is having these two sides, so it's going to be A squared plus B squared minus 2 AB cos of angle A. So this is something which I wanted to just remind you, which is taught in grade 11 as well. Sine rule, area rule, and cosine rule. Are you happy, guys? Are we still together, guys? Are we still together? Are we still moving together? We're still moving together. All right, now I'm done with the question, the overview. Now I want us to do a few questions together, and I'm gonna combine questions as well, and I'm gonna post them in the group so that you can be able to practice more, because practice makes perfect. Practice makes perfect. Practice makes perfect. Practice makes perfect. All right. Now let's now get to the real deal, to the real questions now. This is adapted in 2015 final exams. I think it's a November exam. Yes, November paper, DBE, of mathematics grade 12. So I'm gonna do the questions. Question 5, question 6, question 7. Yes, I'm gonna do those 3 questions. Okay, so please be with me and let's assist each other and do this question together and just get total marks. Just look how do you do that. All right, question 5. Let's go now. Question 5, we have 5.1.1.1. All right, so given that sine of 23 degrees is equivalent to K, square root of K, determine in its simplest form the value of each of the following in terms of K without using a calculator. That's amazing. This is a nice question. Now I want you to look at this. So we know that sine of any angle is always equal to opposite over hypotenuse. So now we are given that sine of K. Okay, so now we are given here in this question that sine of 23 degrees is equal to square root of K. So what do we do in this instance? We know that sine of any angle is always equal to opposite side over hypotenuse. So in this case, our hypotenuse it's 1. So now we must draw our Cartesian plane so that we can be able to solve this question. All right. Let me put it in the quadrant 1. First quadrant, 90 degrees, and we're having 23 degrees, which is the angle which we have, angle 23 degrees. So the opposite side is root K, and it's 1 hypotenuse. So we can also calculate x. How do you calculate x? You know that r squared is equal to x squared plus y squared, and now we want to calculate x squared, so x squared will be equal to 1 squared minus y squared. In this case, y squared is root K all squared. Okay, then after that you can be able to see that x is equivalent to square root of 1 minus k. Okay, because square root of k times k, it also always give us the same answer, or the same according to the rules of exponents. So it's the same. So now we can say that our x is equivalent to 1 minus k. So it's equivalent to 1 minus k. Always show this working. Bear in mind that I haven't started answering my question, but I'm already analyzing that I'm given that sine 23 degrees is equal to root k. And what do I know about the trig ratio sign? I know that sine of 23 degrees is always equal to the opposite side over the hypotenuse. So it's also in this instant, what is our hypotenuse? It's 1, because we're only given root of k. So I did this and illustrated this in a Cartesian plane. So also I advise that you illustrate your calculations in the Cartesian plane, because there's always answer in determining the value of x or the value of y in your Cartesian plane. Now we can be able to answer our question without anyone giving us problems, giving us worries, because our triangle is already full. Okay. Now the first question is say 5.1.5.1. They are saying determine sine of 203. Okay, sine 203. Sine 203. So now again, when you're answering trigonometry, when you're answering in your exam, the first thing which you do, you must make sure that you have your reduction formula. Okay. And the reduction formula says that O sine, tan, and cos theta. Okay, you must know that this is 90, this is 180, and this is 270, this is 0, and also 360. So in this case, we are told to calculate sine of 203. So now that's where the reduction formula gets in. So where is 203 degrees located? It is located in the third quadrant, because you have to say 180 degrees plus, and 203 degrees is between 180 and 270. So it's located in the third quadrant. So what does it do? We just do this sine of 180 degrees, because it's 180 degrees. You can see that in the third quadrant. You still remember on a quadratic, we said on a reduction formula, we said that it's always 180 degrees plus something. So now in order for us to get this angle here, what do we do, guys? In order for you to do this, you must say 180 degrees plus the missing box. I'm taking you back to grade 0, grade 1 is equivalent to 2 or 3. Then now you calculate the missing box. It will be 203 minus 180 degrees, then it's 23 degrees. Okay, so always know that this missing box is 23 degrees. So also you also, when you're having this kind of question, maybe you're given 400 degrees, maybe you're given 320 degrees. Where is 320 degrees situated? It is in the fourth quadrant. So how do you calculate in the fourth quadrant? We know that in the fourth quadrant is 360 degrees minus. So which angle, which small angle, when we subtract, is going to give us 320 degrees. Okay. So the same thing applies also in this question, that we just say 360 minus 320, and we get our 40 degrees. So when we say 360 degrees minus 40 degrees, we get 320. So that's how we do it. Okay, so now we have written it in this format. Now it's now sine 180 degrees plus 23 degrees. So the next step is, now we are now determining, now according to the reduction formula, 180 degrees plus any angle is in the third quadrant, and in the third quadrant only tan of theta is positive and other angles are negative. So we now have negative sine of 23. Now we have reduced it. That's reduction, reducing from 180 to small angles. Okay, then we know that from this Cartesian plane, sine of 23 degrees is root k over 1. So now our answer here will be equivalent to negative root k over 1, which is the same as negative root k. Okay, so that's our answer which is needed here. Okay, any question? That's the answer which is needed here. Then going to 5.1.2, cos 23. Cos 23 is equal to, so again, now we have already have our Cartesian, and you know the cos 23 is always equal to adjacent over hypotenuse. So what is our adjacent? We calculated our adjacent using the Pythagoras theorem, and you get x is equal to root 1 minus k. So in this case, our cos 23, it's 3 marks. So you must start by that Cartesian plane now, but we are just writing because we have already determined it. So it's so important that you start by determining the angle, and also you determine the sides also as well. So now this will be equivalent to, help me please, we say that it will be equivalent to root 1 minus k over 1, which is the same as root 1 minus k. Okay, then we also have 5.1.3 5.1.3. So on our 5.1.3, the question says that determine tan of negative 23. We say that tan of any negative angle is always equal to tan of 23 degrees. What is tan 23? We know tan 23 degrees is always opposite over hypotenuse. So again, we come here. So it's going to opposite. What is our opposite side? Negative root k over adjacent, which is 1 minus k, 1 minus root k. And we know that according to the rules of sets, it's the same as k over 1 minus k, just like this. So it's one and the same thing, but this sign also, don't forget it. So we are done and dusted with the first question. Is there anyone with any question? Is there anyone with any question? Okay, right now let's look at the 5.2 now. It's a bit tricky, but we're gonna tackle and see what we can get. 5.2, we are given that 4 cos of negative x times cos of 90 degrees plus x, all divided by sine of 30 degrees minus x, okay, times it's not times, it's plus, or times cos x, sorry, plus cos of 30 degrees minus x times sine of x. Okay, all right. So when you're doing trigonometry, apply everything which you have been taught. Okay, so now let's get to this. And let's attack this question, and let's answer this question together, guys. Let's answer it together. You see that it's easy. Okay, cos of any negative angle, it's always positive cos. Okay, then now cos of 90 degrees plus x, that's a co-ratio. The moment you hear cos and you hear 90 degrees plus something, that's a co-ratio. Don't worry yourself, don't even worry or stress about anything. The fact that they are telling you that it's 90 degrees plus x, know that it's a co-ratio. But we know that now 90 degrees plus x is in the second quadrant, and of course it's negative in the same quadrant, in the second quadrant. So also the co-ratio will be also negative. And now at the bottom are given sine 30 degrees minus x times cos x plus cos. So look, my mind is running. Oh, when I was taught about compound angles, we must understand that compound angles, we have sine cos, cos sine, cos sine sine. So in this case, you are having sine cos, cos sine. So we can just write that in the term of a compound angle, since it's positive, which means it's a plus b. So it's going to be 30 degrees minus x, that's our a, plus x, that's our b. Okay, easy. So now we have negative 4, because now we want to remove the bracket. Negative 4 sine of x times cos of x divided by sine of 30 degrees. Okay, because negative x plus x is always equal to 0. Then now we have negative 4 sine x cos x divided by, according to the special triangles which we did, now we did them together. We say that 60 degrees, it's 30 degrees, it's 90, it's root 3, it's 2, it's 1. So we can see that sine of 30, it's 1 over 2. So always know your special triangles as well. Then these are the same numbers, they are like terms. So when you divide both of them, you're gonna have negative 8 sine of x times cos of x. Then when we have negative 4 2 sine x times cos x. We can see that this is a double angle because they said simplify as much as you can. So we can see that if we say 2 times 4, it's -8. So we can see that it's a double angle, and it's a double angle of 2x, sine 2x. Okay, so that's our answer. Let me repeat what happened here. So we were given initially that 4. Initially we were given that 4. Okay, so initially we were given that 4 cos negative x times cos of x 90 degrees plus x divided by sine cos sine. So the first thing which we saw that we started by here. So here we are given that cos of a negative angle, and since we said on our review and our revision, we say that cos of any negative answer is always equal to positive cos of x, then this is where we are. Then we said also in our review that we have what we call co-ratios. So the sine 90, sine and cos, they alternate, they change, they intertwine when they arrive at 90 degrees. That's why they are called co-ratios. So when you're given sine 90 degrees plus or minus theta, it will change to cos of theta. Then when you're given cos of 90 degrees plus, it will change to negative sine of theta. If you're given sine of 90 degrees minus, it will change to positive sine of theta. So those are our co-ratios. So in this instance also we are given this co-ratio, and we know that this co-ratio, it will lead us to have negative sine of x. Why? Because 90 degrees plus x is in the second quadrant, and we know that cos in the second quadrant, it's negative. So since cos is negative in the second quadrant, our co-ratio is also going to be negative. Then also at the denominator now, when we are reading it, sine 30 minus x cos, we realize that it's sine cos sine. So when every time when it's sine cos sine, or cos cosine, your mind must think that these are compound angles. So in this instance also we saw that sine cos cosine. So bear in mind that since it's sine cos cosine, this is a compound angle. Then we apply the compound angle that says sine of a plus b because of the positive sign which we have here. Then after that we were able to solve it, and we say that this is a special angle. So we use a special triangle for the special angle. Then we're able to get our 1/2. Then like terms, then we're able to get -8. But we saw that there's sine x and cos x. Then we saw that we can have a double angle here, because we know that sine of 2x is always equal to 2 sine of x times cos of x. So since we had 8 here, so when you say 4 times 2, it's still 8. So that's why I put this brackets here, so that you can see that these times this, they're multiplying each other, so that these two, when you multiply them, they'll give us -8. Okay, then after that we're able to arrive to this final solution, which is -4 sine 2x. Then we have our solution. Is there anyone with any question? Then we have our solution. All right, good. Due to time, guys, let's just finish this first question. Then I'll try to have another session on this aspect as well. Please forgive me for that, because due to time, we can't spend more time. But I love the fact that this question have many questions which touched all aspects. Okay, so on 5.3, determine the general solution of that. Okay, general solution, what are we given? We're given cos 2x minus 7 cos of x minus 3 is equal to 0. It's 6 marks. So how can we determine that co-ratio, that general solution? So we know that in order for us to determine that general solution in 5.3, we must understand that we are given. And so what do you do in this instance? So in this instance, we are given a double angle. So we must simplify the double angles. So when you simplify this, we're going to have 2 cos squared of x minus 1 minus 7 cos of x minus 3 equal to 0. Then it's 2 cos squared of x minus 7 cos of x minus 4 is equal to 0. So this is practically a double angle. So since we know that cos 2x is a double angle and it has 3 solutions, which is 2 cos squared of x minus 1, we also have 1 minus 2 sine squared of x, also have cos squared of x minus sine squared of x. So we decided that no, let's use cos, since we are having cos in our equation. So if we're having sine, we're supposed to use the one with sine. So now we are here. Then check it out. This is also the same as 2 x squared minus 7x minus 4 is equal to 0, because these cos squared and x, they are the same thing. So I always advise that you see that this is now a binomial, this is now a quadratic equation. Okay, so you can solve this quadratic equation because you know. So if these costs, they are disturbing you, I always, and I would really love to advise you right now that you can just say let cos of x be equal to x, because you are used to x. Then now where you see cos, you place it with x squared minus 7x minus 4 is equivalent to 0. Then after that you find factors, or you use the quadratic formula. It's either you find factors or use the quadratic formula. So in this way, when you find our factors, we're gonna have x here, we're gonna also have 2x 2x plus 1, yeah 2x plus 1, and also gonna have x minus 4, okay, equal to 0. So these are our factors. Then we end up having 2x plus 1 is equal to 0, or x minus 4 is equal to 0. Then our x will be equal to 1 over 2, or our x will be equal to 4. Then what do you do after that? Then but x is equal to cos of x. Still remember that this is what you said. You substituted and said let cos of x be equal to x. So now you must bring it back. So where there's x, now you are putting what? The cos of x. Or now our cos of x is equal to 4. Then now we must determine the general solution. So we know that the general solution of course is always in this format. Okay, so we know that when we do this one, first one, it's gonna be cos of x equal to 1 over 2. So we must calculate the calculated angle here. The calculated angle will be cos inverse of 1 over 2. Always that's the case, guys. Calculated angle of 1 over 2. Let me just check something. Oh, I'm sorry, guys. Remember that it was plus 1, so when it transposes, it's going to be negative 1. So it's negative 1 over 2 here, so that we have cos of negative 1 over 2. So the inverse of cos of negative 1 over 2, that will give us 120 degrees. Let me just do this before I say general solution. Let me solve for x. Let me solve for the angle first, okay? So that you can see the angles. Or we can solve it, x is equal to cos inverse of 4. Then you use your calculator. It is gonna say error or syntax errors, which means there is no solution. So please write this no solution, because there is a mark for being able to depict that surely there is no solution. So since this is cos and we're having the calculated angle, we know that the general solution of cos is always equal to x is equal to the calculated angle plus or minus the calculated angle, okay, plus or minus the calculated angle plus 360 degrees of k, where k is the element of real numbers. Reveal the question, review. Okay, so what happened is that we were given that determine the general solution of cos 2x minus 7 cos x minus 3. Then we were able to realize that we are having a double angle in our equation, so we had to transform the double angle, which is cos 2x, into one of these three. So since we are dealing with x here, with cos here, so I decided to use this first double angle, and now we had 2 cos squared x minus 1 minus 7 cos x minus 3. Then I grouped like terms negative 1 and negative 3 to get negative 4. Then I realized that this is a quadratic equation, but I might be confused by having this cos and cos. So that's where I said let cos x be equal to x, so that wherever there is cos, you substitute with x. So someone was not going to be confused. So from this step, someone was just going to find the factors automatically without saying let cos x be equal to x. So that I'm doing this so that I can accommodate two people, someone who will be able to understand with cos x and someone who will be able to need x first, so that you can realize this is a quadratic equation, then solve it in that format. So that's why I said yes, let cos x be equal to x. Then when there was x, I place it with when there was cos x, I replace with x squared. Then I have here and replace with my x. Then now this is something which is relevant, which is a quadratic equation. Then I solved my quadratic equation. But after I was done, we say that x is equal to cos of x. So now we are substituting back our cos x to where there is x. So cos x is equal to -1/2, or cos x is equal to 4. Then now we are calculating the angle. So the calculated angle, we know that we say x and we transpose cos. We can't divide. It's called arc sine or arc cos or arc tan. So in this case, it's arc cos of cos of -1/2. Then we get x to be 120 degrees, and also we have no solution. Then also now finally we know that the general solution of a cos, it's always plus or minus the calculated angle plus 360 degrees of k, where k is the element of integers. Okay, is there anyone with any question? Okay, let me do the last question. It's 5 marks. Wow, it's 5 marks. Given that sine theta is equal to 1/3, calculate the numeric value of sine 3 theta without using a calculator. Wow, that one is gonna take us time. There's nothing impossible under the sun. So in this question, we are given that we must calculate sine of 3 theta. So we know that sine of 3 theta is the same as sine of 2 theta plus theta. Okay, that's something we know, because when we add theta plus 2 theta, we still get our 3 theta. Okay, so when we have that now, we can be able to see that this is a compound angle. So that will be equivalent to sine of 2 theta times cos of theta, okay, plus cos of 2 theta times sine of theta. Okay, so now we can see that we are having that instance there. All right, so after that we can now change. This is a double angle, so let's change this one into a double angle. That will be 2 sine of theta times cos theta times cos theta. Then you can also see that this is a double angle, so I also advise that you change, but check it out. We are dealing with sine mostly, so you can change it using the sine one, which we have. It's 1 minus 2 sine squared of theta times sine theta. Okay, and now let's solve. We're gonna have 2 sine theta cos squared of theta plus 1 plus sine theta times 1 is sine of theta minus 2 sine cubed of theta. Okay, that's 2 sine of theta. Then we can have our sine theta here as a common factor. See, we can have our sine theta as a common factor here, so that we can solve this thing without having more troubles, you know. So we can do that as well. We can also do that so that we can have more solutions. But nonetheless, though, we can see that we are having cos squared here. We can change that cos squared also, because it's an identity. So that can be 1 minus sine squared of theta, ne? Yes, plus sine theta minus 2 sine cubed of theta. So guys, we are just applying what we did and combining every information which we have. So sine theta times 1 is sine 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta. Then now we can see that 2 sine theta plus plus sine theta is 3 sine of theta, and we can also see that -2 minus 2 is -4 sine cubed of theta. And what were we told? We were told that sine theta is equal to 1/3. So we have 1/3 minus 4 1/3 or cube. Then now we can solve using our calculator. That's 3/3 minus 4/9. Yeah, it's 3/3 minus no, 3 squared is 27. Sorry. Then we have 1 minus 4/27. Then always use your calculator here. Then it's 27 is the common denominator. 27 1 minus 4, so it's gonna have 23/27. Oh, that one was quite horrible. It was quite long, but let me just redo it. Let me revisit. So we are given that sine 3 theta is equivalent to, so calculate sine 3 theta if we are given that sine theta is equivalent to 1/3. So what I did first was to break the 3 theta into 2, and I had 2 theta plus theta. So bear in mind that 2 theta plus theta will give us 3 theta. So now I saw that now this is a compound angle. Then that's when we break the compound angle. It's sine, so it's going to be sine cos, cos sine. So I break the compound angle. Then I was able to reach here 2 sine theta times cos theta, because okay, after this step, then I saw that these two are double angles. So I was like, okay, I want to deal with sine since we're having the double angle of sine here. So I had 2 sine theta times cos theta. This is the solution of this double angle, and I transformed also this double angle into this 1 minus 2 sine squared of theta. Then after that, I had this 2 sine theta, then cos times cos is cos theta. Okay, so this 2 minus this times this 2, they'll give me this one. All right, then also on this side, also this thing times this is sine theta, this times this, we had this. Now also I see that I'm having one cos and I'm having sine, so I decided to convert this cos squared into 1 minus sine squared of theta. Remember my identities in grade 11, I say that cos squared of theta or cos squared of x plus sine squared of x is always equal to 1. So since they are always equal to 1, we can just chuckle around with that and say cos squared of theta, making it the subject of a formula, is equivalent to 1 minus sine squared of theta. Then we end up having 2 sine theta minus okay, then 2 sine theta times 1 is 2 sine theta, so we multiply this as a scalar multiply. Then 2 sine theta times negative sine squared of theta, that would be negative 2 sine cubed of theta, plus sine theta minus 2 sine cubed of theta. Then after that, 2 sine theta, we are seeing that there are common terms. 2 sine theta plus sine theta, that's 3 sine theta. The negative 2 sine cube theta minus negative 2 sine theta is negative 4 sine cube theta. Then after that, you substitute the condition which you are given, that sine theta is 1 over 3. So sine theta is 1 over 3 and sine theta is 1 over 3 without forgetting the cube root. Then we'll be able to use our calculator and get this as the final answer. 5 marks. Is there anyone with any question? Is there anyone who has a question on that part? Is there anyone with any question on that part? Okay. Due to time, guys, we will finish this and finish it up next week. You meet me next week on Thursday, I think. Next week Thursday, or Monday and Thursday twice, so that we revisit the trigonometry and refinish it. So this is my part 1 actually as well. It's my part 1 because I wanted us to do graph, but also due to time, I can't be able to do graphs now today. But also graphs, they are not hard. It's just the matter of using your calculator. So we're gonna do graphs next week of trigonometry, as well as applying the sine and cosine rule. Okay, then we can be able to get our 40 marks. But the most important part which I wanted us to do today is this one with 24 marks, because everything is covered in this section, and everything which is here, we did it today. If you have any question, please don't hesitate to ask your question. There will be the link under the description of this video. You'll see the link to join the WhatsApp group. If you want to join the WhatsApp group, please do join, so that we can interact. If you have any problem, if you have any question, so that we can assist each other. The main goal is for you to be assisted, for you to be helped and be able to receive good marks and pass well. Please do share the link with friends and family. Please do share. Till we meet again, may God bless you and have a great evening.